Okay, so the first part of this lesson is very, very straightforward. All today is how we can combine functions. And there's 5 different ways we can combine functions. The first 4 are very, very straightforward. The algebra part of it is not going to be complicated. But what we want to add to it is the identification of the domain. Okay, I think I said range before. We're not going to worry about the range. I will take that back. We're going to worry about the domain. So we can combine functions as long as their domains overlap. If I have a function that's only negative values for the domain and another function that's only positive numbers for the domain, there's no way we could add those together or subtract them because they have no x's in common. So as long as they have even a part of the domain in common, wherever they overlap, we can combine those functions by adding them, would be way number 1. What I want to show you here is just the function notation of these. All right, I know you know how to add, but I want you to be aware of how the function notation is going to look. What do you think the next one's going to be? You can subtract them. And I said there's 4 of them. Multiply and divide. Thank you. Now I have a note down here that says when we're taking the quotient and we're taking f of x divided by g of x cannot equal 0. Why? We can't divide by 0. So that's really going to be our biggest challenge, is to think about when that denominator can't be 0. We will have to consider that for our domain. All right? If we have a fraction, we cannot let that denominator be 0. So we're going to go through some very basic examples, just so we can kind of review some things. Some of the things that we talk about are things that maybe came up on that quiz number 1, which I'm going to try to hand back to you today. I haven't updated your grades. I have them written down. I'm going to type those in today. Okay. So what I want you to do is, at the very least, write down these 2 functions for me. As you write them down, consider what type of functions these are. Think about what type of functions these are. If we were to graph them, what would we get? Gabriel, if we graph these, what would we get? We would get lines. These are linear functions. Okay, and what do we know about the domain of linear functions? All real numbers. As long as we have any sort of polynomial, we have a domain of all real numbers. We don't even need the graph. So this guy has a domain of all real numbers. This guy has a domain of all real numbers. Do they overlap? Yes. Even if one of them had a domain of like 0 to infinity and one of them had a domain of all real numbers, they would overlap from 0 to infinity and we could combine them there. So we're going to go through each of these 4 combinations. Okay. I'll get it. F plus g of x. Can't put it in the parentheses where I didn't want it. Okay, f plus g of x. That's the notation I had written over here, right? Okay. F of x is 2x minus 5. And we're going to add g of x. Okay. Guy, what do we have?
X minus 3.
We combine like terms. Our sum is x minus 3. We had overlapping domains, which is all real numbers. We ended up with x minus 3, which everybody has a domain of what? All real numbers. X minus 3 is still a linear equation, so its domain is going to be, third time. F minus g of x. I want to talk about this because this is a mistake that was made not only on the quiz, but even on some people's corrections. Okay? When we take a function like 2x minus 5, that doesn't even necessarily need to be in parentheses, but 2x minus 5, and we are subtracting a function, we need to subtract that function in its entirety. Okay? This is something that was definitely overlooked, both on the quiz and for some people on their corrections. Okay? We are subtracting the entire g of x. So what happens? We have 2x minus 5 minus 2 plus x. Please be careful to distribute that subtraction through. So our function is 3x minus 7. Emily B., what's the domain of 3x minus 7? All real numbers. We have a linear equation. Okay. Really, the only time you're going to have to be really worried about it is if we have like a fraction, we don't want that denominator to equal 0, or if we had a square root. The square root was one of the few graphs on your 8 basic function chart where your domain wasn't everything. Okay. We can't have negatives under the radicals, so we're going to have to be careful there. All right. F times g of x. Okay. Just make sure, once again, you are multiplying the functions in their entirety. So when we take 2x minus 5 and we multiply by 2 minus x, is that how we're going to write it? Probably going to write it in parentheses. Okay, go ahead and take 1 minute, FOIL that out, and combine like terms.
don't know, like, if you use like that. I can't figure out how to
Alright, Chelsea, what did you get for your x minus what? Minus 10? What do you think? Plus 9x. Okay, let's look at this. So 2x times 2 is 4x, right? 2x times negative x is your negative x squared. Negative 5 times 2 is the negative 10. And then negative 5 times negative x would be a positive 5x. So we have 4x plus 5x to get 9x for our middle term. Okay? Be careful about those negatives and positives. So, Chelsea, thank you for being brave and sharing your answer with me.
put this one out.
There's our product. Our product is a quadratic. Quadratic's domains are real numbers. Okay. Don't be bored, guys. Okay. Our fourth combination is division. This probably takes the least amount of algebra because we're going to take f and divide it by g, and we're done.
Really?
Is there anything that we can reduce?
Can't you do like the long division though? Or do you need that?
I mean, we could do long division, but that would not be necessary in this case. We can just leave it as a fraction, okay? There's nothing we can reduce down, like there's no factors that can cancel, okay? I know some people are looking at these twos like, ooh, those are very tempting, but they're not. We would have to factor a number out. Things have to be separated by multiplication if we want to cancel in a division problem. So we're just going to leave it like this. However, our domain is not all real numbers. Okay, so Monique says x cannot equal 2. 2 does what to the denominator? Makes it 0. Whatever makes this 0, we have to exclude. So if we want to exclude 2, then we want everything to the left of 2 and everything to the right of 2. Okay, that interval notation that we practiced last week, this is where it's really going to come into play.
I was gonna say.
What?
Was it wrong to put domain cannot equal
Yes, because I want interval notation. Okay? On your test, and for that matter, your quiz tomorrow, interval notation for everything. Okay? That is my expectation now. Okay? Now, the fifth way we are going to combine things is what's called the composition. All right? You did work with this on your Friday quiz last week, the composition. I want to make you aware that there are two different notations. All right? This circle, and I think you've seen that in Algebra 2, right? That circle. F composed with G. F composed with G. Maybe, maybe not.
Oh yeah.
It does look like fog.
What you talking? Because I remember this. I saw it. You said the circle.
Okay. So it's okay if you haven't seen the fog. All right. F composed with G just means F of G of X. Okay. We're taking one function and we're putting it into another function. That is what you did with, I think it was number 4 on your quiz. Okay, it had 3 parts to it. Now the algebra, we still have to work out a little bit, okay? But we're also going to talk about the domain of a composition function, okay? And what happens is we have to consider whatever is on the inside, we need to think about its domain. And then we're going to plug it into F and consider what that domain is. And then see where those two overlap, okay? So I have kind of a picture here that you can see. And when I scroll up, okay. Please keep in mind that when we talk about rules in mathematics, we always have to talk about them in general before we can get to a specific example. So sometimes when we're on a page like this and you're like, what are you talking about, Mrs. Holden? At least write down what I have. And if it's not clicking immediately, don't be alarmed, because sometimes it takes a specific example for us to wrap our minds around it. So when we talk about a composition function, okay, whatever is on the inside, we have to think about first. All right, no matter if we're plugging in a number, if we're doing the composition, or if we're doing the domain, okay? We always have to think about that inside function. So we first need to consider what x's belong, okay? So if g of x is our inside function, what x's belong there? Like, can we have all real numbers? Do we need to exclude the negative ones? Do we have a fraction that we need to exclude that number from? Once you have done the composition, then you also need to consider which x's belong. So, hold on, let me back up. We take g of x and we throw it into our function f, right? We do the composition. And then at that point, we need to think about the domain. What x's belong in our new function that we just composed, okay? Then we're going to take a look at those two and see where they overlap, okay? If g of x has a restricted domain, but somehow the composition is all real numbers, we still have to stick with that restricted domain because we plug into g of x first. If g of x has a domain of all real numbers, but when we do the composition, there are x values that don't work, we have to consider that and take those away. So what I want you to do is I want you to write down f of x and g of x. Okay. This is the last thing we're doing today. Okay. Write down those two functions. We're going to find the composition. We're going to find the domain, and then we should have time for me to give you your quizzes back. Okay. Here's also where your transformation of functions will come in handy. Okay. X squared minus 4. That's a parabola shifted down 4. We know that the domain of any parabola is all real numbers, right? Okay, g of x is a square root function shifted to the right 3. Okay, well, if we think about the parent function of radical x, its domain is what? Okay. For our parent function, it would be everything greater than 0, right? If we shift it to the right 3, okay, which we wouldn't have to do, we could think about that mentally. If we shift it to the right 3, our domain becomes everything bigger than 3, okay? We don't have to actually graph it to get the domain. We can think about what that graph is going to look like and then determine it from there. But if you want to draw a picture, you can. So as far as the composition is concerned, we are taking g of x and we're plugging it into f. So this would be my advice to you. First, write it as f of g of x. And we always start with the inside. Our inside function is g. So I'm going to go ahead and I'm going to change g to radical x minus 3. Okay. Now our job is to take radical x minus 3 and plug it into f. So anywhere there's an x in our function f, we're going to replace it with this right here. So function f is x squared minus 4, but instead of x, we have to write our g function. Yes?
Since it's squared, do we even need square root?
Okay, so my next step would be then to see that, okay, I have a square root squared. So when we reduce it down, you're right, that square root and square will cancel. And our composition ends up being x minus 7. So here's where we need to take a step back and think about the domain. Before we do that, are there any questions on the algebra that we just completed? We took G and we plugged it into F. Wherever there was an X, we replaced it. Okay. Now, if I were to ask you for the domain of X minus 7 out of context of this problem, what would you say? You would say all real numbers because it's a linear function. However, we had to begin by plugging in g of x. And what are the only numbers that can be plugged into g of x? Everything greater than 3 or equal to 3, right? So while, yes, x minus 7 has a domain of all real numbers, since it came from a composition where we plug into g of x first, we have to consider the overlap of this domain. So g of x has a domain of 3 to infinity. Our result would have a domain of all real numbers, but we have to look at where those overlap. So our domain for the composition would be 3 to infinity. So essentially, you want to look at the domain of the inside, the domain of your results, and then see where they overlap. Okay? Really, that's the only new thing that we've done today. Okay? However, some of us do need some more practice on our algebra with composition. Okay, so this will be a good assignment to get that practice in. Now we have about 5 minutes left in class. Let me go ahead and stop the video, and then I want to talk about your quiz evaluations.